Alright, this video is first going to go over the balanced equations packet because you'll need this for the notes and for your homework. So this is out of 76 points. You'll have this to show me in class. So each coefficient's worth a half point. If it's a formula of a substance, it's going to be worth 1 point. If you don't have the right answer, you have to put the right answer because you're going to fill these into your homework and notes packet, and so you want to have the right answers. All right, so here we go. 2, 2, 3. For A, B is 1, 2, 1, 4. C is 3, FeSO4 plus 1, Cu3, PO4, 2. Arrow 1, Fe3, PO4, 2, plus 3, CuSO4. D is 2Al plus 3 PbNO3, 2. Arrow 2, AlNO3, 3, plus 3 Pb. E is 2 C2H2 plus 5O2, arrow 4 CO2 plus 2H2O. F is 1 CH4 plus 2O2, arrow 1 CO2 plus 2H2O. Remember, 1 is understood, so if you don't have anything there, that's fine. 11 is 1, 3, arrow 2. For 12, we have 2, arrow 2, 3. 13 is 1, 2, arrow 1, 1. 14 is 1, 5, 3, 4. 15 is 1, 1, 3, 1. Write how many you miss at the bottom. Remember, if you have the wrong answer, you want to make sure you have the correct answer. Onto the back, you should have 2, 1, arrow 2, 1. 17, 1, 6, arrow 4. 18, 1, 2, arrow 2. Ag plus 1, Ni, NO3, 2. 19 is 2, Ca plus 1, O2 yields 2, CaO. 2, NaClO3, arrow 2, NaCl plus 3, O2. And you could have the 3, O2 in front. 21 is 2H2 plus 1, O2 gives you 2H2O. 22 is 4 Na plus 1 O2 gives you 2 Na2O. 23 is 1, 2, arrow 1 CO2 plus 2 H2O. 24 is 2 H3PO4 plus 3 Zn, arrow 1, Zn3, PO4 in parentheses 2 plus 3 H2. And the last one is 1, 1, arrow 1, Fe, NO3 in parentheses 2 plus 1 Cu. So please make sure you have a score out of 76. Okay, now what we're going to do is have our homework packet. You turned in 12-1, so now we're looking at 12-2, and we're also going to have our notes out. So I have my notes out, and I have my packet here. So I'm going to go ahead and fill these in. So in my notes, so I'm on the notes, this one says equation A. Notice how this is equation A, 2, arrow 2, 3. So I'm going to fill in 2, arrow 2, 3. And then I'm going to go ahead and do that for all the other ones. These have to be filled in before we do these stoichiometry problems because you have to have balanced equations. B was 1, 2, 1, 4. I'm sorry. Yep. C, 3 in front of FeSO4. 1 here. 1, 3. D is 2, 3, 2, 3. E is over here on page 3 of the notes. We should have 2, 5, 4, 2. F is 1, 2, 1, 2. So we have filled in A through F. These were from the notes. Okay. Now we're going to go to our homework packet, and you should do the same thing. So you're doing homework 12-2 today for homework. So I'm going to go ahead and look at number 16, which is on the back, right? So you have here 2, 1, 2, 1, 17, right? So according to my balanced equations here, it's 1, 6, arrow 4. So I'm going to put 1, 6, arrow 4. 18, I should have 1, 2, and then 2 AG plus 1 NI NO3 2. 19 is 2 CA plus 1 O2 gives us 2 CaO. 20, 2 NaClO3 arrow 2 NaCl plus 3 O2. And then we move on to the back page of 12-2. Once again, I'm following the numbers here, so I'm going to fill in 21 to 25. So here for this balanced equation for number 21, I should have 2H2 plus 1 O2 gives you 2H2O. For 22, 4 Na plus 1 O2 gives you 2 Na2O. 23, 1, 2 gives you 1 CO2 plus 2 H2O. 24 is 2 H3PO4 plus 3 ZN, arrow 1 ZN3 PO4 2 plus 3 H2. These are all 1, and then 1 Fe NO3 2 plus 1 Cu. So balancing these equations beforehand has saved us quite a bit of time. Imagine if you had to balance all these equations before doing 12-2. Most likely your homework would take so much longer, right? And so now that we've already balanced the equations, we can definitely continue with figuring out stoichiometry problems. So now what we're going to do is look at day 2 of stoichiometry. So now what we're going to do is complete day 2 of chapter 12 notes. So you should have your notes out. Turn to page 2. It says notes on it, right? Page 2. We filled out these balanced equations, and we're looking at day 2. All right, on top of page 2, we know that every stoichiometry problem involves moving from one substance to another. So how do I recognize that I'm going from one substance to another? Here's a good example. How many grams of H2, so notice how it's one thing, does it take to make 647 grams of H2O? So I'm going from one substance all the way to a different substance. And when I do that, I have to use the mole ratio. The only way to move from one substance to another is the mole ratio. What information can I use for stoichiometry? I can use, once again, the mole ratio. I can use molar mass, which is the value from the periodic table, and I can use Avogadro's number, which deals with particles. So now we're going to look at problem 1. Remember that every stoichiometry problem uses the mole ratio. So on day 1, I had you put a circle around it or a heart. We're going to continue to do that so that you can recognize that in order to go from one substance to a completely different substance, you have to use the mole ratio. All right, so let's look at this problem. How many grams of water could be produced if 10.0 grams of hydrogen were reacted with excess oxygen? All right, the first thing is that it says excess oxygen. And excess oxygen means that it has extra of it, and we don't care that it's going to limit our reaction, and that's what we're going to learn later in this chapter. So, if I'm looking at my stoichiometry island diagram, that's here, right? If I look at my stoichiometry island diagram, I want to know how to convert grams of H2 to something completely different, grams of H2O, two completely different masses. So I'm going to go from here to here. All right? Remember, you're going to put a heart or a circle around the mole to mole ratio. But what you can see is that this is definitely 1, 2, 3 steps. All right? I can't go straight to moles. I have to go from mass to moles using molar mass, then from mole to mole using the mole ratio, and then mole to mass using the molar mass on the periodic table. So I'm going to go ahead and do that. So here I have I need to cancel out grams of H2. The only thing that I know that goes with grams is moles. So that has to be moles of the same thing, moles of H2. And so I'm at this step, right? Mass to moles. It's 1 mole of that substance, molar mass, grams on periodic table. So 1 goes with the mole, right? And then what I have to do now is look at my periodic table. The molar mass of H is 1.0 times 2 is 2.0. Now I want to cancel moles of H2, so I put moles of H2, right? And I want this substance, H2O. The only way I can go from moles of one substance to a completely different substance is to use the mole to mole ratio. So moles of H2O, so this coefficient here is going to go here, and this coefficient here is going to go here. Remember, this is the mole to mole ratio, so I'm going to put a heart around it. So now moles of H2 cancel, right? Grams of H2 already canceled. I have to keep going till I get the unit that I do want on top. So I'm going to go ahead and put mole of H2O down here. Mole of H2O. And what I want on top are grams of H2O. So I'm going to go ahead and put grams of H2O up here. And if I'm looking at my stoichiometry island diagram, 1 mole equals molar mass on grams from the periodic table. So this is where I add up the molar mass on the periodic table, 2 times H, so that's 1.0. So 1.0 times 2 is 2.0 plus oxygen is 16.0, that's 18.0, and 1 goes with the mole. So now, I like to put a heart around the mole ratio because I love chemistry or like chemistry, right? But I don't know how you feel about chemistry. Hopefully you can at least tolerate it, right? But the reason why is because this is the only time we look at the coefficients in the balanced equation. Chapter 10 was where 1 goes with the mole. So notice how 1 is still going with the mole. If it's outside of the mole ratio, 1 has to go with mole every time. So if I circled it, if I put a heart around it, It may or may not have a 1. It depends on the coefficients in the balanced equation. But if it's outside the mole ratio and it has the word mole with it, it better have a 1. Okay? So now I go ahead and put this in my calculator. So when I put this in my calculator, I'm going to take, right, everything on top is multiplied. So 10.0 times 1, which is the same number, times 2 times 18.0, right, divided by 2.0, divided by 2, and that gives me 90. But I got to check my sig figs. So with sig figs, right, this is 3 sig figs. Careful with H, 2 sig figs. Unlimited for the mole ratio, 3 sig figs. So I need to round to least amount, 2 sig figs. How do I make 90 into 2 sig figs? I can put a decimal, or I could put it in scientific notation, 9.0 times 10 to the first grams of H2O. All right, so now let's do the next problem. How many grams of nitrogen gas will be produced when 123.8 grams of hydrazine reacts with hydrogen peroxide? So my given is the measurement that has one number, 1 unit, right? So I'm going to write 123.8 grams, and it says hydrazine, so that's N2H4. And I'm trying to find how many grams of nitrogen gas. So what if I accidentally just put grams of N? Balanced equation, there's nothing that's just N. So I probably wrote it wrong. It's N2, which is this one, right? It's a diatomic when it's by itself. So very similar to problem 1. I'm going from grams of one substance to grams of a completely different substance. So I got to use their molar mass of the given. Then I have to go from mole to mole using the mole ratio, and then from moles to mass using molar mass on the periodic table. Now, I'm going to go ahead and put my grams of N2H4 here. When I put my grams of N2H4 here, I am going to put mole on top. This isn't a mole ratio, so 1 goes with the mole. To figure out what number goes here, I have to use the periodic table. So I know that the molar mass of nitrogen is 14, so 14 times 2 is 28, plus 4, because 4 times 1.0 is 4.0, I get 32. So 32.0 is the molar mass of NH4. That cancels. Now I got to go to the next step. I don't want moles of N2H4 down, so I'm going to put that down here. Now I'm at the point that I can put a mole ratio. So I'm going to put the mole of the substance that I do want on top. Here is where I put the mole to mole ratio. This is where I'm going to look at the coefficients in the balanced equation. 1 goes here, N2H4. 1 goes here because it's a 1 here. But I'm still not done, even though I kind of wrote really big over here, right? I'm going to cancel out now moles of N2, so I'm going to put moles of N2. And what I want are grams of N2, so I'm going to put grams of N2 up here. 1 goes with the mole. Molar mass of N2 would be 2 N's. 14.0 times 2 would be 28.0. So remember, if it's the mole ratio, coefficients come from the balanced equation. Outside of that, right, 1 should go with the mole. 1, 1. So now I'm ready to put this in my calculator. So I'm going to take 123.8 times, multiply everything on top, times 28.0 divided by 32.0. And I got 108.325. But how many sig figs should I have? Well, this one has 4 sig figs, 3 sig figs, unlimited, 3 sig figs. So I'm going to round to 3 sig figs. 1, 2, 3. Look at the neighbor. So my final answer is 108 grams of N2. Number 3. How many grams of Fe3PO4 could be produced when 12.04 grams of FeSO4 was reacted with HCCh12Day2? So I'm going to set up my workspace and write what I'm trying to find after I write my given. So it's 12.04 grams of FeSO4. And I'm trying to find how many grams of Fe3PO4. So this is where it gets a little complicated, because what students will do is they won't mess up on the stoichiometry problem. What they're going to mess up on is finding the molar masses. So let's make sure that we find the molar masses correctly. If I'm looking at my stoichiometry island diagram, once again, I'm going from mass to mass. So it's going to be a 1, 2, 3 step problem where I'm going to use the molar masses again. So here I need the molar mass of FeSO4. And believe it or not, for some reason, I feel like it just helps students when they write it out. So Fe, S, and O, right? So Fe is 55.8. S is 32.1, and O is 4 times 16. So I put that all in my calculator, 55.8 plus 32.1 plus 4 times 16. And I get 151.9. And then mole goes on top. Now what goes up here? Should I put a 3? No, because this is not a mole to mole ratio. This is molar mass. This is chapter 10. 1 goes with the mole. Grams cancel. My next step is my mole to mole ratio. I'm going to have moles of FeSO4 down here. And what I want on top are moles of Fe3PO4. So here, 1, FeSO4, 3. Remember, this one is the only one that can have coefficients from the balanced equation. So now the moles of FeSO4 cancel. Mole of Fe3PO4 here. 1 goes with the mole. Up here is where I'm going to put my molar mass. Once again, it helps when students write out molar mass. Why? Because you're allowing yourself to process the information. So I'm going to have Fe, P, and O. So Fe is 55.8, but I'm going to multiply that by 3. Phosphorus is 31.0, but I'm going to multiply that by 2. And oxygen is 16.0, but I'm going to multiply that by 8. So 55.8 times 3. I'm going to add that to 31.0 times 2. And then 16 times 8. I get 357.4. So let's go ahead and put everything in our calculators. Everything on top, 12.04 times 1 is the same number, so times 357.4 divided by, right, divided by 151.9 divided by 3. And I got 9.442826. Let's count our sig figs. Here I have 4 sig figs, 4, unlimited. Mole ratio is always unlimited, 4. So I need 4 sig figs. 1, 2, 3, 4. Look at the neighbor. My final answer is 9.44, rounds up, 3 grams of Fe3PO42. Okay. Last one in the notes. How many atoms of lead are produced when 29.6 grams of aluminum reacts with PbNO32? So here's what happens. We've been going from grams to grams, grams to grams, grams to grams. But now this one down here wants atoms. So I'm going to start with my given, 29.6 grams of Al. Set up my workspace, right? And in the end, I don't want grams, I want atoms of lead. Well, what's lead? Pb. So how is this different on my stoichiometry island diagram? I'm going from mass to particles. So my first step is going from mass to moles, which means I'm going to use molar mass. And I'm going to use my mole to mole ratio, where I'm going to use the coefficients in the balanced equation. And I'm going to go from moles to particles using Avogadro's number. Remember, 1 always goes with the mole if it's not a part of the mole to mole ratio. So here we go. I want grams of Al to cancel. The only way I can do that is by using moles of Al on top. 1 goes with the mole. It's not a mole ratio. The molar mass of Al is 27.0. Grams of Al cancel. The next step is where I can use my mole to mole ratio. Not my best heart there, right? Mole of Al over moles of Pb. Now, what goes here? Coefficients from the balanced equation. 3, because 3 is in front of Pb, 2 in front of Al. Moles of Al cancel. I want to cancel mole of Pb, so that goes down here. I'm trying to find atoms, though, not mass, atoms. Atoms of Pb. So these are particles. 1 always goes with the mole outside of the mole to mole ratio. These are particles. That's Avogadro's number. Okay. Now I put this in my calculator. To put this in my calculator, I'm going to take, right, 29.6 times 3 times 6.02 second E 23 divided by 27 divided by 2. And I get 9.8995 times 10 to the 23rd. Well, how many sig figs do I need? 3 sig figs, 3 sig figs, unlimited, 3 sig figs. So I'm going to round 3 sig figs. 1, 2, 3, look at the neighbor. So my final answer is going to be 9.90, don't forget the power of 10, times 10 to the 23 atoms of Pb. And that's my final answer. So what's your homework? Your homework is 12.2. So we have our 12.2 that we've already filled in all of our balanced equations. And 16 to 20 are mass problems. 21 to 25 are mass and particles. Okay? I'd be careful with sig figs on 21. All right? And then you will have this ready to grade in class tomorrow.